Thank you.
That is super cool. All right. Thanks, Tom. That's an awesome beginning. So my name is Jesse, everyone, and welcome to Exploring by the Seat of Your Pants. This is all about bringing conservation, adventure, and science into classrooms around the world. And we're really excited to start off a new year with all you guys. 2020 is off to a fantastic start. We got 16 sessions this week alone, which is crazy. And so today, although all month long we're celebrating Epic Earth, today we're going to go a little bit off Earth. I'll explain a little bit about that in a second. But first, we've got 3 classes joining us from across North America. So I want to give them a chance to say hi. They're all Ontario today. It's and Tom and I are both in Ontario too. It's a provincial celebration. We've got Miss Nelson's and a second class, grade 6s in Bowmanville, Ontario. So welcome in, guys. Hey everyone. Wow, there's so many of you. I love it. We've got Miss Parrish's grade 5, 6s in Petrolia, also in Ontario, like I said. Hey, welcome back. Oh, these are like the biggest classes ever. All right, and then last but not least, Mrs. Kokenyaji's grade 6s in London, in Ontario, as I said as well. Welcome in. Hey, guys.
Hi.
Hey. All right. Of course, the reason you guys are all here today is for our speaker. So we are joined live by Tom Vassos, and he is a huge space nut. He lives and breathes exploration and astronomy. So today is going to take us in with space exploration discoveries. What have we discovered in the last many years? The Mars, the Moon, comets, asteroids, the planets in our solar system, from the Apollo moon landing to the present day. Tom's going to take us on a journey to explore what we've learned about space. So without further ado, thank you so much for joining us, Tom, and thanks for that cool video to start us off, and take it away.
Thanks so much, Jesse. Looking forward to today's session. We're going to be talking about space exploration discoveries. And I'm going to focus not on space exploration discoveries like using telescopes like the Hubble telescope and stuff like that, but actual discoveries where astronauts and rovers and things like that are kind of hanging around different planets and moons and things like that, and see what kinds of discoveries that they have actually made. So let me just switch over into my presentation, and we're going to take a close look at some of what these discoveries are. And I thought I would start off with the topic of space exploration beginnings, because it's kind of interesting to see what happened. A lot of this space exploration happened before many of you were born. And so I want to ask a first question. Jesse, if you could open it up to all the audiences.
Sure.
Can anyone yell out the answer to this if you happen to know? Does anyone happen to know who was the first to orbit in space?
Yep, you guys are all demuted. Anyone want to yell it out?
Anyone know who was first to orbit in space?
Neil Armstrong we got. Anyone else?
Okay. That's a lot of the common names you would think, but guess what? It wasn't Neil Armstrong or Buzz Aldrin. It was actually this monkey that took a suborbital flight back over 70 years ago. That's right. They had to test it out with somebody, and this monkey called Albert 1 was the lucky one. But that was just a suborbital flight. The next thing up in space was this dog named Laika that the Russians sent up over 60 years ago. And I'm a dog lover, so I don't want to tell you the end of this story, but unfortunately, I will just tell you that there is actually a monument in Russia honoring this dog. They even have some stamps honoring Laika the dog that was the first to take an orbital flight into space, which is kind of an interesting history of how this all began. But I thought I would start with a tour of the International Space Station, because a lot of what we do as space exploration discoveries in the last 20 or 30 years has happened on the International Space Station. And to do that, we're going to have to take a trip on a spacecraft, a rocket ship, to get up there. And this is the Discovery spacecraft. And so this thing weighs more than 10 African elephants. But I got another quiz question for you. What is faster? Everyone has to answer one of these two. I'll give you a chance in just a second. What's faster, the speed of sound or this rocket ship? Just raise your hand and yell out speed of sound if you think it's the speed of sound. Now, go ahead.
Yeah, about half, I'd say. Yeah.
Okay. Yell out if you think it's this rocket ship. Yell out this rocket ship.
rocket ship.
That's right. This rocket ship is actually faster than the speed of sound. There it is here, breaking through the sound barrier. In fact, not only does this rocket ship go faster than the speed of sound, it goes 22 times faster than the speed of sound. So it's actually quite fast. The International Space Station is actually the most expensive object ever built. About 195 billion Canadian dollars, or about 160 or so billion US dollars. And this is what it looks like. Wow, it's larger than a football field. And they couldn't make it all at once, so they had to kind of build it like a Lego set. They just kept bringing up different pieces of it at a time. And now it's orbiting around planet Earth for many, many years. So here's what I want to do first. I want to talk about the top 12 reasons why you should want to become an astronaut and work on the ISS, International Space Station, when you grow up. So here goes. Reason number 12, weightlessness is cool. And here's the guy playing with his fidget spinner. Look, he doesn't even have to hold it. It's just floating in midair. Wouldn't you like to be able to do that and show your friends? But unfortunately, weightlessness has its disadvantages too, like Marcia Ivins found out on this day where she was having a bad hair day in microgravity, okay? And reason number 11, they have a great supply of drinking water. What they don't tell you, kids, is that when you're on the ISS, you have to drink recycled sweat and urine from the other astronauts. That's right. No fresh water up there. But let me ask you a question, Jesse, open it up again. Can anyone guess why we don't simply just, every time a shuttle goes up, bring these astronauts some nice fresh water up to the International Space Station? Anyone have any idea?
You guys know?
The London class, what do you guys think?
Because the water will go everywhere. Water go everywhere.
Water go everywhere. Any other reason?
Well, here's why. It's surprising, but guess what? To bring these 5 bottles of water up to the International Space Station would cost about $50,000 because we have to break this stuff free of Earth's gravity. And that takes a lot of fuel. So that's why we have to get them to drink recycled sweat and urine on the International Space Station. Reason number 10, they have a great gym, but what they don't tell you is you have to exercise vigorously for 2 hours every single day. Otherwise, your bones and muscles will waste away. Let's hear from Canadian astronaut Chris Hadfield about exercising.
It's cool. It gets you do things you just can't do anywhere else. You can fly and float and turn, but it doesn't come for free. Without constant load on your body, you can get incredibly lazy. Your muscles will start dissolving. Your bones will start getting reabsorbed back into your body. So to stay strong, to go out on a spacewalk and fight the spacesuit, or so you're strong enough to walk around when you get home again, we have to exercise. We have to demand that our body stays strong. And we do that at various exercise equipment here on the space station, including T2, treadmill number 2, the Terminator, right here on the space station. Time to exercise.
So Chris Hadfield talks about when an astronaut goes up to the ISS, literally as soon as they get up there, their bones start to waste away, thinking that they don't need to be there because there's no gravity. So here he is exercising. And look, he has to be strapped down to the treadmill, otherwise he would just float away. Okay, we'll come back to Chris again in a few minutes. There's also time for fun on the ISS. Here's an astronaut blowing bubbles into his water. If his mom could see him now. Or how about playing sports like badminton?
Astronauts aboard the International Space Station played the first game of badminton in space. American astronauts teamed up against Russian cosmonauts and a Japanese astronaut for a doubles game, which looks even harder to play in space.
Okay. And then there's this NASA astronaut that decided to play ping pong with a ball of water, which is floating in midair. And what he's doing there is he's using something called hydrophobic paddles that doesn't attract the water. And he can actually have a game of ping pong with a ball of water. Reason number 8, it's very safe. Yeah, when I look at this picture, I say, yeah, as long as you're holding on for dear life, right? And here's an actual spacewalk that an astronaut is taking. Look at the view that he gets from the International Space Station. Both him and the ISS are traveling at 27,000 kilometers an hour, 10 times faster than a speeding bullet. So I hope he straps himself in, otherwise he wouldn't want to float away. And check out that beautiful view of planet Earth below. So I hope you're not scared of heights if you want to be an astronaut. Reason number 7, they have a well-stocked refrigerator. Not. Unfortunately, all they get up there on the ISS is canned, dehydrated, and packaged foods. Let's have some dinner with astronaut Chris Hadfield.
To prepare the spinach, you just attach it to the water distributor, choose the right quantity, and push the button. And it's like magic. Dried spinach, and spinach ready to eat.
So there you have it, kids. Eat your spinach and you'll be an astronaut when you grow up. All right, thanks, Chris. Here's a few astronauts having dinner in the kitchen. Just open it up, Jesse. Can anyone tell me what is missing from this kitchen?
Yeah, how about Petroleus class?
Everything.
Cutlery, seats, everything is the best
Okay,
answer.
no, they got some cutlery. Look, the astronaut's using a spoon there, but one of the things that's missing is kitchen chairs. You don't need kitchen chairs, you just float around. And the other thing I like to tell people that's missing is salt and pepper shakers, because you wouldn't want to throw salt and pepper all over the ISS because it would just float around. And the ISS even has 2 bathrooms. That's right, you have to use a funnel when you go to the bathroom. And guess what? Every year the astronauts put into this toilet about 1,000 kilograms of feces, which then gets shot out into the atmosphere and it burns up in Earth's atmosphere as it makes its way back to Earth. So all I can say is if you're looking up, kids, and you see a shooting star, who knows what it is, right? Okay. And reason number 3, you get to do cool science experiments like this one by Chris Hadfield.
So here's a common question. Can you cry in space? Do tears work? Well, let's try it out. I can't cry on command, but I'm going to take some water, drinking water, put it in my eye just as if I was crying. Let's see what happens. Okay, so nice and stable for you here. Here we go. So, just as if I started crying, my eye is full of tears. But you can see it just forms a ball on my eye. In fact, I can put more water in. And so if you keep crying, you just end up with a bigger and bigger ball of water in your eye. Until eventually it crosses across your nose and gets into your other eye, or evaporates, or maybe spreads over your cheek. Or you grab a towel and dry it up. So yes, I've gotten things in my eye. Your eyes will definitely cry in space, but the big difference is tears don't fall.
Reason number 2, it has a great view out of a 360-degree bay window called the cupola. And you get a really unique perspective of planet Earth. And here's a perspective from above of a volcano. I had the pleasure of meeting Canadian astronaut Roberta Bondar a couple of years ago, and she was amazed when she was orbiting Earth. She talked about how with each orbit of Earth, she would see 30 to 50 active volcanoes. It's like the Earth is this living, breathing thing. And we don't get this perspective from planet Earth, but you certainly see it when you're up in outer space. Reason number one, you get to fly around the entire planet Earth every 90 minutes. Let's get a time-lapse view of what that would look like from the astronaut's point of view. You can see here the city lights glowing at night. You can see these flashes here. Can anyone guess what these are? Just open it up.
Yeah. What do you guys think? What are the flashes, Miss Nelson's class? Thunderstorms.
That's right. They're lightning bolts. And if you're traveling around Earth every 90 minutes you get to see a sunrise and a sunset. So here comes a sunrise on the left side of your screen coming up now. Here's a view going south over Florida, and there's Miami well lit, and Cuba. And here's a view going south in Europe. There's Italy. Look how brightly lit Italy is. And we're about to see the Nile River and Jerusalem and the West Bank right there. Look at the Nile River, how well lit it is on the right side there, and Jerusalem, the West Bank. And there you can see the northern lights from above. Just a beautiful sight that the astronauts get to see. All right, let's move on to space exploration. We're going to start with Mars because a lot of people don't realize there's been over 20 successful missions to Mars, landing all kinds of rovers and things like that. Humans have never landed on Mars, but some amazing discoveries have made this. Later, InSight Landing is even going to dig underground to see if it can measure earthquakes and maybe even find some life underground on Mars, which we have never found. But all kinds of discoveries that have been made on Mars, frozen polar caps and evidence of underground water a couple of kilometers below the surface. So all kinds of things like that. Another recent mission called the Parker Solar Probe on a 7-year journey to visit the sun. And it's already been orbiting around the sun, getting closer and closer and closer to measure the sun's heat and solar flares and different things like that. And the main spokesperson for this mission is actually someone from Star Trek, Captain Kirk, as some people might know it if you've ever watched Star Trek. And he talks about this mission, but guess what? They gave Earthlings a chance to put their name on this Parker Solar Probe. And I had the pleasure of adding my name onto that list. So my name is on its way to the sun on this Parker Solar Probe to make some amazing discoveries. Next, there's this 50th anniversary last year of the Apollo mission of landing on the moon. And most of you kids weren't even born then. So I wanted to share with you just a brief video. The person talking here is John F. Kennedy, who was the president of the United States, which really spearheaded this mission to the moon. Let's take a look at that.
The exploration of space will go ahead, and it is one of the great adventures of all time. Its conquest deserves the best of all mankind. For we meet in an hour of change, in a decade of hope, in an age of knowledge. Even though I realize that this is, in some measure, an act of faith and vision, for we do not now know what benefits await us. But if I were to say, my fellow citizens, that we shall send to the moon, 240,000 miles away, a giant rocket carrying all the equipment needed for survival on an untried mission to an unknown celestial body, and then return it safely to Earth, re-entering the atmosphere at speeds of over 25,000 miles per hour, and do all this and do it right before this decade is out, then we must be bold. The exploration of space will go ahead, and it is one of the great adventures of all time.
It's one small step for man, one giant leap for mankind.
For the eyes of the world now looking to space, to the moon, and to the planets beyond. We set sail on this new sea because there is new knowledge to be gained. But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon, and this we cannot do the other thing. Not because they are easy, but because they are hard. The exploration of space will go ahead, and it is one of the great adventures of all time.
So although we haven't been back to the moon in almost 50 years, guess what? In your lifetime, probably in about 5 years from now, humankind is going to land back on the moon, and possibly even in the next 20 years or so on planet Mars. So you kids will be experiencing some of the greatest adventures in space exploration. I wanted to mention a couple of other missions, though, that have happened since that moon landing. One was the Chinese with their Chang'e lander landing on the far side of the moon just last year, which was a great accomplishment. And they even did the first biological growth experiment on the moon, planting a bunch of seeds to see if they could grow anything on the moon. And guess what? Cotton seeds actually sprouted on the moon. So I guess you could say we have the makings of the first farm on the moon. And here's a rocket ship from SpaceX landing back on planet Earth. And they actually landed 3 spaceships that were in orbit back on planet Earth on their landing pads. And the big breakthrough here is that these spacecraft are reusable. Back in the olden days, every time we would make one of these missions, we would basically throw away the rocket ship. But now these rocket ships are reusable, dramatically decreasing the cost of space exploration by about 90%. Then there was the Cassini mission to Saturn. The Cassini spacecraft actually orbited Saturn for over 20 years, taking these amazing images. Now, this is a speeded up animation because this journey would take quite a long time, but these are actual images from that Cassini spacecraft in making some amazing discoveries orbiting around Saturn. In fact, just before the Cassini spacecraft was decommissioned and crashing into Saturn, it actually flew right through the rings just to see if it could do it, you know, and getting some of these amazing images. The other cool thing that Cassini did was, with the help of the European Space Agency, they actually dropped a probe on one of Saturn's moons called Titan. And in this animation, you can see how they planned to land it, because they didn't know what was on Titan because it was total cloud cover. So they were shocked when they actually landed on Saturn's moon Titan, because what they found was the only other world in our solar system that actually has liquid flowing on its surface. Now, you might think that, wow, liquid flowing on its surface, we should dive into this lake and have a bit of a swim. Well, I don't recommend you do that because it's a couple of 100 degrees below zero, and this isn't water, this is liquid ethane and methane. But nonetheless, scientists were intrigued by it because these are like rivers flowing down to lakes, flowing into hundreds of lakes on Saturn's moon Titan. But they're planning future missions because even though this is a couple of 100 degrees below the zero, there could still be life forming in these lakes, life that's probably very different than what we have on planet Earth. Then there was this mission to Comet 67P. This is a cool mission. This particular comet's about 5 kilometers across, and it's traveling 50 times faster than a speeding bullet. And guess what? The European Space Agency said, hey, let's create a mission to go visit it and rendezvous with it 1/3 of a billion kilometers away, a mission that was going to take 10 years. And guess what? In 2014, they actually reached this comet with the Rosetta spacecraft, but they even went one step further and actually released something called the Philae lander to actually land on this comet 1/3 of a billion kilometers away. Now, mind you, they had a bit of a problem trying to land this thing. Some of the thrusters and harpoons failed, and it actually took 3 bounces off the surface of the comet, but it actually did settle down and land on this comet long enough to take measurements and photos and different things like that. And this is actually a photo taken by the Rosetta spacecraft of this amazing comet. Not only did we get beautiful images of it, but some amazing discoveries were made, like the fact that this comet contains water vapor and carbon, hydrogen, and oxygen. They even found 16 organic compounds and 1 amino acid. Why is that important? Because these are the precursors to life. So they didn't actually find life on this comet, but they found the elements that could actually form life. So a lot of people suspect that these comets landing on Earth billions of years ago could have kickstarted life on planet Earth. And the final mission I wanted to share with you is the Japanese mission called the Hayabusa 2 mission, where they actually wanted to land on an asteroid called Huygen. And they actually threw 5 beanbags onto the asteroid. And the purpose of throwing these beanbags onto the asteroid was so that their cameras could focus and take some really clear pictures. And then they actually landed some robots on this asteroid, which were kind of walking around taking all kinds of pictures and measurements and things like that. But they even went one step further. They released something onto the asteroid, which is this little box here. And I'll show you how they did that. So they released this box, and this box is called the mascot lander, so that this lander could land on the asteroid and roll around and take all kinds of measurements. So this lander is actually rolling around this asteroid as we speak, which is just an amazing exploration discovery. And it has all kinds of instruments like a wide angle camera and a magnetometer and an infrared microscope, all kinds of things that we can make discoveries about this asteroid. The other cool thing is the most amazing part of this mission that I wanted to show you, they actually have a sampler horn, because they said, hey, while we're here, why don't we take some rock samples and bring them back to Earth? So let me tell you how they did that. First of all, they released an impactor, and they got out of the way with their spacecraft, but they released the impactor so it could blow a hole into the asteroid so that they could take a sample of some of the soil and rocks underneath the surface. So then they dipped down, they took some soil samples, and then they raised back up into the orbit around this particular asteroid. So just an amazing scientific achievement. And they're in orbit along with that asteroid, but guess what? Now they're starting to leave the orbit of the asteroid, and now you can see the spacecraft is going to try this year to join the orbit of Earth. And once it joins the orbit of Earth and gets really close to planet Earth, it's going to release that re-entry capsule, which contains that soil sample that it grabbed from the asteroid, and it's going to drop that sample back to planet Earth. So the re-entry capsule has to have a very powerful heat shield, and then guess what? It will then release, bring that soil sample back to planet Earth by the end of this year. The space tourism industry has already started. This Canadian astronaut for $35 million got to visit the International Space Station. And so kids, in your lifetime, you're going to actually be able to to potentially take a trip into orbit or suborbital space as the price of that trip drops down further and further. So in closing, the interesting thing with all of these space exploration missions is we came all this way to explore the moon, and the most important thing is that we discovered the Earth, according to an Apollo 8 astronaut. And this astronaut, the vast loneliness is awe-inspiring, and it makes you realize just what you have back here on planet Earth. That was Jim Lovell, one of the Apollo astronauts. And in closing, we'll never have all the answers about the universe, but the quest to unravel its mysteries can be our greatest inspiration. And with that, I'll turn it back to Jesse for our question and answer session.
Well, thank you so much for that, Tom. What a fantastic presentation. And yes, in addition to our 3 classes live, we've got 2 classes watching in from Thornton in Colorado, and possibly some more. We got 5 groups watching right now. So if you guys want to type in your questions in the chat bar, I'll take as many as I can. But let's get started with some live classes. So let's head first to Bowmanville. You guys have a question to kick us off? Come on up.
Our first question is from Hunter.
Go ahead,
Hunter, right
Hunter.
from there.
What happens if the capsule from the robot or something doesn't hit like Earth? It misses it.
Yeah.
Okay, so that's interesting. If it missed Earth, it would probably just head out into open space, or it might get trapped in Earth's orbit and just simply start orbiting around Earth. But that would be bad. But these scientists are so smart. They know exactly when to drop that capsule, how close they need to be to Earth to drop the capsule to make sure that it actually lands on planet Earth. But I will give you another story about that Japanese Hayabusa 2 mission that I told you about. They actually had the Hayabusa 1 mission where they actually tried to drop a lander onto that asteroid, and they didn't drop it at the right time. So that lander missed the asteroid and is now floating in space somewhere. So sometimes we do miss our target, and then things will just float in outer space. Great question.
Yeah, the math and engineering behind orbits and getting things to land properly is incredible. And again, 90% of the time we do a really good job, but that's a great story of when we didn't quite get it right. All right, let's head to London. If you guys have a question, go for it.
Jacob, you're our first person. Nice smile, though.
Will the Earth ever stop rotating? And if it did, what would happen?
Ooh.
Okay, the question is, will the Earth stop rotating? And if so, what will happen? Okay, so first of all, it probably will never stop rotating, but I will tell you that right now our day is 24 hours, so it takes 24 hours for the Earth to rotate once. But guess what? Several billion years ago, I think it was something like the Earth's rotation was only like 8 or 9 hours or something. So over time, Earth's rotation is actually slowing down. So who knows, a billion or 2 from now, it could be down to 23 or 22 or 21 hours. So it is actually slowing, but we don't think it will actually stop. Now, as that slowing occurs, hopefully the human circadian rhythm will get used to that shorter day to get used to when we need to sleep and not sleep. So that's an interesting question.
I will also, there's a comic series from a former NASA engineer. He writes under XKCD, and he literally did an entire thing in his book all on what would happen if the Earth actually stopped rotating. It's not good. It's very bad. Pretty much everything dies. The whole Earth is scoured by like a turbo wind. It's very exciting.
Yeah,
anyway.
Just as an aside on that one, we are rotating around the Earth at 1,200 kilometers an hour, roughly half the speed of a speeding bullet. So if the Earth instantly stopped rotating, we would go flying in that direction, half the speed of a speeding bullet, because we wouldn't stop right away.
Also not good. That's funny. All right, let's head to Petroleum. If you guys have a question, come on up.
Do you sleep in space?
How do you sleep in space?
Good question. How do you sleep in space? So there's no gravity. So what the astronauts actually do is they have a sleeping bag that is tethered to the wall. They get inside the sleeping bag, they zip up that sleeping bag so that they don't float away during the night. And then they can actually sleep in that sleeping in that sleeping bag. Chris Hadfield, I've seen him on previous talks talk about it. It's kind of hard to sleep because you're floating around all day and then you're just floating again when it's time to sleep. So it's hard to get used to that process of getting asleep.
Yeah, great question, guys. All right, Ms. Rago's class in Thornton, Colorado wanted to ask, do you think there are planets that we have not discovered yet?
Okay, so I'll make that a two-part question. Do we think there's any planets in our solar system that we haven't discovered yet? Well, there is a lot of talk about far, far beyond the orbit of Pluto that there could be this other planet, and sometimes people call it Planet 9 or Planet X. And it has never been discovered, although there's a lot of things moving around in the Kuiper Belt, which is way out there, billions of kilometers away, that are moving around in a very strange fashion. So a lot of scientists think maybe there is a big planet out there, and that's why all of those other comets and asteroids that are billions of kilometers away are moving away strangely. We have a lot of a lot of telescopes right now surveying all of that area, and in the next 10 years we could discover a large planet out there, but up until now it hasn't been found. The part B of that question is, might we find planets beyond our solar system orbiting stars billions, if not trillions of kilometers away? And the answer to that is yes. We have had many spacecraft missions that have found thousands of what's called exoplanets, planets orbiting distant stars. And now there's other missions like one called TESS that I'm sure is going to find thousands of more planets orbiting other stars in the universe. And the thing that we're really looking for in those planets is ones that are located in the habitable zone so that potentially we can find life in the future on those planets orbiting distant stars.
Super cool. All right. We're going to head to Bowmanville. We're going to take two questions, but I know you guys have two classes together. So we'll start with one, and then you can come up right after for a second, okay?
Do you guys think of who has one from your class? All right, our next question is from Dawson.
Okay, Dawson, go ahead.
Has any asteroids crashed into any planets yet?
Okay, great question. Let's talk about Earth specifically. First of all, we know that asteroids are crashing into all planets and all moons all the time because we see the craters. If you look at the moon, it's loaded with craters all over the place. Those same asteroids and comets, yes, have crashed into Earth in the past. So it's predicted that 65 million years ago, an asteroid about 10 kilometers across crashed into planet Earth in the Yucatan Peninsula near Mexico and destroyed about 75% of all life on planet Earth, and it killed off all of the dinosaurs. So that was an asteroid crash into Earth that had a huge impact on planet Earth. Most recently, there was one that came in over Russia just a few years ago, and that particular one exploded in the sky, but the explosion was powerful enough that it blew out thousands of windows that came crashing in houses and buildings, commercial buildings, and it actually caused so much damage that it sent about 1,000 people to the hospital. So sometimes these asteroids coming into planet Earth can wreak havoc on planet Earth, but we just hope they're small enough that they don't cause too much damage like the one that hit planet Earth 65 million years ago. The other aside on that one is we're actually getting pretty good at monitoring every single asteroid that is potentially on a collision course with Earth that can cause some major damage. And NASA actually has the technology that if we do find one of these big asteroids that is going to cause a bunch of damage on planet Earth, that we can actually go out there and potentially change its orbit so that it misses planet Earth. So there's a lot of cool science going on, keeping our eye on these asteroids and deciding whether we have to change the course of one of them in the future so that we can save all life on planet Earth.
Outstanding. Thanks, Tom. All right, let's head back to Bowmanville. Actually, give me a quick second. We'll go to Petrolia, but you guys are heading out in a second. So Petrolia's class, if you guys have a question before you go, come on up.
Alex? Come on up, Alex.
Take your time, you're all good.
Go ahead.
When that asteroid comes to Earth, will it get caught in its orbit and become a second moon?
Ooh, interesting question. I like it.
Okay, so the question was, will that asteroid potentially get caught in our orbit? And the answer is possibly yes. If it's coming in on a certain angle, it could get caught in Earth's orbit and we could all of a sudden have a new moon. In fact, the two moons that are orbiting Mars, I think they're called Phobos and Deimos, scientists actually think that's how they got caught in Mars's orbit, that they got close enough and they were small enough that they didn't crash into Mars, but they just slowly started orbiting around, and that's how they became moons of Saturn, or sorry, moons of Mars. In fact, the long-term prediction of what those moons are going to do is that they are going to orbit Mars for millions of years, but one of them has an orbit that's degrading and is eventually going to crash into Mars, and another one is moving away from Mars, so it's actually going to leave Mars one day. In fact, a lot of people don't realize our own moon is actually moving away from us. Its orbit is moving away from us about 1 inch or 2 or 3 centimeters every single year. So that's not very much, but potentially a billion years from now, even our moon could leave us. So that's another interesting aside there.
Super cool. Thanks, Tom. And thanks to the Petrolia class for getting in one last question. I know you guys got to go, but we really appreciate you joining us today. That's awesome, guys. All right, let's go back to Bowmanville. We'll finish up with London and take one more from a YouTube class as well. So Bowmanville, come on back up, guys.
What was the longest space expedition?
Yeah.
Hey, what's the longest space expedition? Well, it depends how you define space expedition. We'll talk about two different kinds. Missions that don't have humans as part of it. So we've had missions to Mars, for example, where we've had rovers there for years and years and years, just roving around. In fact, some of those rovers, the original mission was only for them to last on the surface of Mars for about 3 months. And some of them have lasted for almost 10 years. Okay, so some of these missions without humans are very long. Missions with humans, the ones to the moon, for example, were only a few days. It was 3 days to get there, a day hanging out on the moon and doing some experimenting on the moon itself and walking around, and then back in 3 days. But then the mission on the International Space Station, because I consider that a mission as well, that one has been going on for over 20 years. But each astronaut just goes up for 6 months at a time. The longest mission that one astronaut had, Scott Kelly, was almost 1 full year. So that's a bit about the missions and the length of time. I will make one other mention about length of time for missions, because it's very quick to get to the moon and back, but to get to Mars, that's not a 3-day trip, that's an 8-month trip. So if we're going to send actual humans to Mars, it's going to take 8 months to get there, and then maybe they're going to hang out there. Well, they're either going to come back right away, or they're going to wait 2 years for the next window to get a ride back to planet Earth, which will then take another 8 months. And that's going to wreak havoc on their bodies, because when you're traveling there in microgravity, as you heard from Chris Hadfield, your bones waste away, your muscles waste away. So humans really weren't meant to take these long missions on a place that doesn't have gravity like it is on planet Earth. So that's a bit about some of the length of time of different missions.
Excellent. All right, last 2 questions. So Miss Brock's class, also in Colorado, wanted to ask, how many people can be on the space station at a time, and what countries have people on the space station?
Okay, so the countries that have people on the space station is always varying, because every 6 months they rotate around. So Canada, United States, Russia, Japan, European countries like Italy and other ones like that. So we've had all kinds of countries. I don't know exactly which ones are there now, but I know we almost always have some American astronauts up there. Chris Hadfield was the mission commander. He's from Canada, so he did 3 missions up there. So it just varies country by country because this $160 billion was funded by several countries from around the world. So they all get a chance to send an astronaut up there to do some experiments.
Yeah. Canada's next astronauts, by the way. So our next person scheduled to go into space is Jeremy Hansen. George St. Pierre just got back a few. David St. Jacques, sorry, David St. Jacques. George St. Pierre did not go to space. David St. Jacques just got back from the space station not too long ago. And then Jenny Seide and Josh Kutrick just graduated from astronaut training camp the other day. So it's a really exciting time.
And to answer how many, typically the number of people on the space station at any time tends to be around 5, 6, or 7. They probably could have more than that, but that's probably the comfortable number for the food they have and the number of experiments that are being done and things like that.
Excellent. All right. And then we'll wrap up with one last question from London's class. Come on up, guys. Go for it.
Okay, this question is coming from Hannah.
Hey, Hannah.
What interesting facts can you tell us about the black hole?
Ooh, black hole facts. We could go all day, Tom.
So black holes, everyone loves to talk about black holes, these amazing things where gravity is so powerful that not even light can escape. And that's why they call it an actual black hole. And Einstein predicted these things 100 years ago, but we actually didn't discover the first one until 50 years ago. But just last year, we actually took the very first picture of a black hole by a set of telescopes called the Event Horizon Telescope, where we actually got a picture of it. So that was really cool. But a couple of unique things about black holes. I love to tell people, you know, try not to fall into one, because if you happen to fall into one, they have a scientific term for it. It's called spaghettification. It'll literally suck you into the black hole, kind of starting with your big toe, one atom at a time, where you will disappear forever. Because once you pass the event horizon, you, just like light, you cannot escape from that black hole. So black holes have these amazing gravitational force. We have discovered that there's a supermassive black hole probably in the center of every single galaxy. Our Milky Way galaxy has a supermassive black hole in the middle of it. It's called Sagittarius A star. And we believe the power of that gravity, which is 4 million times the mass of our sun, is one of the things that keeps all of the stars in the Milky Way galaxy orbiting around in this cool fashion around the Milky Way galaxy where Earth lives. So there's just a few tidbits about black holes.
Excellent. Well, Tom, thank you so much for a fantastic presentation. Before we wrap up, is there a place you'd recommend to classes to go to learn more about space, exploration discoveries, or just in general that we can point people to?
Yeah, there's all kinds of things on the NASA websites. Whenever I'm doing a good Google search about things, you got to be careful what your source is of what that information is that you're seeing, because there's all kinds of websites out there, for example, that will tell you the Earth is flat, and I can assure you the Earth is not flat. So when I do my Google searches, I'll often ask NASA what the answer to a question is. So that's a little bit of one. And Jesse, I know I sent you a copy of my book with a whole bunch of links in it. If you want, you're more than welcome to send that out to the classrooms. There's all kinds of links to NASA websites, planetary websites, Zooniverse, where you can become a citizen scientist and get involved in real NASA data to do things. So there's many sources like that you can get more involved, and then hopefully attend a whole bunch of exploring by the seat of your pants sessions, because I'm hoping with Jesse we can do a session on the birth, evolution, and fate of the universe. So hopefully we can do one about life in the universe and where are all the aliens. So hopefully we can do a lot more exploring with you and your classrooms.
Outstanding. Well, thank you so much, Tom, and we'll certainly be doing those sessions. We highlight space. It's one of our biggest things here, and we always like to highlight exploration and discovery out in the universe. As you know, when we end every session, I'm going to demute every class's microphone, and so boys and girls, if you guys could join me in saying a huge thank you to Tom for joining us today. You are all now demuted. Go for it. Thank you so much, guys. Awesome. We look forward to having you all back really soon. Do check out the rest of the month. Some really great stuff coming in January and then beyond in February. Tom, that was fantastic as always. Thank you so much.
Thanks.